All right, so course. So we started with, pardon me, we were starting just to find our course class. Let's reconnect. And this is a class that takes, the constructor takes one attribute, or sorry, one attribute, effectively, it takes one argument, so it'll have the parameter course name, and then it assigns it to the attribute course name. However, you can see this class actually has two attributes, the name and the list. But the list, referenced by the attribute underscore students, it never got a value passed to the constructor, and that's entirely fine. That's not a requirement. There's nothing to say that the number of parameters and the number of attributes for your class need to match. That's not the same thing. Sometimes they do, sometimes they don't. Because when I create a course, I want it to have a name and for it to start empty. How many people in the course? Well, I just created it. It doesn't exist yet, or it's existing now. How many people are in it? Well, no one yet. So when I create a course, in the same way that when you make a list, how many things are in the list when you make a new empty list? Nothing. Well, when I make a new empty course, I'm going to have 0 things in it. And we also talked about the fact that students, the attribute that references the list, starts with an underscore. And that has special meaning. It's not meaning that Python actually enforces. It doesn't actually enforce anything, but it's a convention that we follow to mean something to other programmers. In the same way that writing all uppercase means to other programmers that this is a constant, leave it alone. Sure, they can change it, but the Python police will come for them. Here, although we can access underscore students from outside the class, we're not supposed to access this attribute directly. It's an attribute that exists inside the class that's important for the class's functionality, but it's not something that someone using this class should interact with directly. And I'll show you a more concrete example of this as we go. All right. Yeah, so it's a convention. It lets other programmers know that all attributes and methods that are not to be accessed directly start with an underscore there. And we're going to add 2 methods to this class, size and add. Cool. Size, well, that's pretty easy. There. That'll be an easy one. How many students are in the class, right? What I want to do is I want to add to the students. And every time I add a student, I'm just going to append them to that list. In fact, let's add that one now real quick. And call it some student. And then what I'll do is self dot some student. There. I added 2 methods. One method that'll return the length. Great. Let's come back to that. Add. Let's look at add first. Add, it takes a student. It'll be a student object of some sort. It'll be a student object. And then all we do is we append it to the list referenced by the attribute students. Now, I'm allowed to access this attribute students because it's within the class. I'm writing a method that exists within the class course, so it's happy. Now, you might notice something, and I talked about this earlier in the semester, but it hasn't come back up. The method add is really, it's just strictly a method that's just one big side effect. It doesn't return anything. It's not like it's a function that takes input and gives output. This method doesn't, it's just a side effect. It adds something to a list. And that is a side effect in and of itself. This is not a pure function. And I know I've been saying we avoid those, but when it comes to data structures like this, side effects is kind of their whole thing. So we kind of deal with that, and we get over it and move on. So once we add a student, I mean, if I ask, like, well, what's the length? Like, if I ask the course, what's its size? Size is just going to hijack, well, what's the length of the list? That's it. So let's run this, and let's make a course. My course.add, and then what's some, well, first, let's print my course.size. And then we'll add some. And what's their course, what's their student number? Who wants to give me a number? 69. All right, you're creative. And, oh no, what did I do wrong? Oh, did I not run this one? Maybe I have to define the student first. There we go. So I create a course, nothing's in it, what's its size? Well, there's 0 things there. Then I add a student, and then I say, okay, what's the size of the course now? Well, it's 1. This shouldn't shock you. This should be fairly straightforward, but it is interesting to see it kind of done the first time, but it's pretty straightforward. We do it again, and then we say print my course.size. There, makes sense, right? Upon creation, there's nothing in it. How big is it? It's empty. I add a student. How big is it? Well, there's 1. I add 2 students. How big is it? 2. There. Cool. Any questions about what we're seeing here so far? All right. So size just hijacks the length of the list. That's it. It's basically like a wrapper method that just calls some other method to do everything. That's nice. That's great when that happens. The method add, the method to remove a student. Okay. Add, we can make use of the list append. And now I'm talking about remove. I guess remove is down here. Find. Okay. So I want to write the methods to remove a student. And I want to also write a method to check if a student exists within a course. Okay? There's 2 more methods I want to write. And to remind you, if we go back up here, we discussed the methods we want for this class. We want, they're in here somewhere. I swear they're in here somewhere. Yeah, a method to add, a method to remove, to get the size, and check if a given student exists in the course. So remove, and checking if a given student exists in the course, well, both of those methods are going to require what? A linear search. To remove a student, well, we got to go and be like, okay, well, where's the student to remove? Okay. And then the contains, the one to check if a given student exists within the course, well, I mean, that's just a linear search. Oh, yeah, there it is, right? They both require a linear search. So, of course, this now goes back to what we talked about in week 2 or whatever it was, where, oh, we've got the same functionality twice. So let's, extract it and make it its own function. So we can write like a linear search function or method for our class. However, let's think for a moment. Remove needs to find the thing and then remove it. Contains just returns a Boolean. Does it exist or does it not exist? So it's not like you could say, well, contains is a linear search, so just use contains. Because, well, I need to know where the thing is to remove it. So that's not going to work. So I'm going to want like another method that will do a linear search. But remember before, like a couple of weeks ago, like a month ago, we started a linear search with return true if it exists, false otherwise. Then I added it, I made it more complex by saying, well, don't tell me true or false, tell me where it is. And if you can't find it, we return that magic sentinel value. Remember that, the -1. It's not saying that the thing exists at index -1, because that's not really a thing. It's saying, well, this has special meaning in the context of a linear search. It doesn't exist. So it wasn't found. So let's make a new function. So we have remove contains, and then we're going to write another function called like find that will find and return the index of the thing I'm looking for. However, remember, we already defined what we want our class to do. Add, size, remove, contains. And now I'm saying, well, I'm just going to make another method. And suddenly that means I'm adding another method. But you know, I didn't really want that method to begin with. I don't want that class to have the method find, to tell me the index of the thing I want to remove. Because also remember, the index, like this class gives me no way to like index the list. I just have add, remove, and contains. I have no way of indexing this list. And that's by design. So suddenly, if I have my class returning the index of where it exists in a list that they're not supposed to interact with directly, that doesn't really make sense. I'm going to revisit what I mean once I show you, and it should clarify things a little bit. But the point is, I want to write a method that's going to be helpful for the inner workings of the class, but shouldn't be acted upon from outside the class. And so we have what we would call, like with the underscore students, which we would often say is a private attribute. It's an attribute that it exists, but it's only existing really, as far as being able to interact with it, inside the class. I shouldn't interact with it outside the class. The same thing goes with methods. We could have private methods as well. Methods that are important to the inner workings of the class, but shouldn't be touched from outside the class. So we're going to write a method called find. If the student is found, it returns the index. If the student's not found, return -1. -1 is that sentinel value. Any questions about what I've said so far? If you're still not quite clear on what I mean, I think once we see the example, it'll solidify things a little bit. So let's write find. Let's just get rid of this. There. So, what do we have here? It's a linear search. This should be very recognizable to you at this point. I'm using enumerate. For I and S, I is the index, S is some student. In enumerate, and what are we enumerating? Well, self.students. If S is the student I'm looking for, return the index of it. If I ever finish that loop and I never find what I'm looking for, I can conclude it wasn't there. So I can return -1. That's our basic linear search right there where it's returning an index. Cool. And I can hit run. But like before, when I go down here and I say my course dot, it doesn't want to include the underscore find. But remember, like I said last time, this is just the editor, the programming environment I'm using. Python doesn't actually stop me from accessing it. I can still do that. But by convention, we don't, and it's such a strong convention that even the editors in their built-in feature of like autocomplete don't even want to show it to you because you shouldn't be touching it. But to show you that I could say find. And you can even see Colab being like, all right, you really want it. And then we can say some student, I don't know, it doesn't matter, 70. And we should see index 0, 1, 2, right? Oh, 0, 1, pardon me. It's the second student, so it's at index 1. Let's get rid of these sizes here. There. So we can still access it, but we really shouldn't have accessed it from outside the class. When I'm saying outside the class, I mean like right here. Inside the class is all of the code written inside the class course. Outside the class is, well, everything outside the class course. Anyone want to take a wild guess why I didn't call this why I didn't call this class? Because otherwise we'd have a class, which, oh my God, it'd be a nightmare. So it's a course. But again, so I can access find outside the class. I'm really not supposed to. So this, what I'm doing here, this is bad. The Python police will come for me. Cool. Okay. Any questions about what we're seeing? By the way, as an aside, sometimes what you'll see, and this is actually very common and in fact arguably really good practice, is you would say like not found equals -1. And then down here you could say like there. Let's see what happens when we return like something that's not there. Oh, what did I do wrong? Not found. What? It's right there. Not. Did I not run it? Maybe it's because it needs to be outside the class. And yeah, I'm sorry, I was using a Java thing. There. Yeah, there we go. Cool. So I returned not found, but that's just -1. But now I've got a constant. I've given the value a name that has special meaning, right? Cool.
What if you put not found in the init instead of?
It wouldn't. I would need to say self dot not found, which is. Let's just not do that.
Yeah, no. I was just curious.
The way I did it up there, that would have been a very Java thing, and that would have worked just fine. But this ain't Java. So there we go. There's our find. Any questions about find before we move on? Well, now let's write our, what do I say? Let's write contains. Well, contains is really easy. If I have, like here's contains. Well, I'm going to check, and here, let's do this. There, now it's even nicer. I'm going to check contains. All contains does is calls find, and if find gives me back anything that's not -1, it's there. It gives me back a -1, meaning does -1 not equal -1? Well, that's false. Oh, well, false. So that's actually it. That contains ends up being quite easy. Now also, because we're using Python lists under the hood, remove ends up being pretty easy too, but we do have a bit of a conundrum. Let's ignore the not contains part. Okay? Ignore that part for a second. Assuming the student is there to be removed, student.pop. If I say .pop on a list, it goes to the list and basically it deletes the thing at that index. So if you have the numbers, or let's say you had the list A, B, C, D, and you had like 0, 1, 2, 3. These are the indices. And you said delete the thing at index 1. Well, B would disappear, and while effectively 1, 2, there. That's what would happen. Yeah. Because we want to be able to remove things from outside the class. I'll show you in a moment. Yeah. Let's just cover what's going on with this exception. Well, we got a bit of a problem. And I mean, some of this is ultimately stemming from the fact that we're dealing with data structures, and data structures are like intrinsically stateful, and we're kind of left going like, well, what do we do? If I say, hey, course, remove this student. All right. And the student exists, what do? Well, you remove the student. If I say remove the student and it doesn't exist, what do I do? I mean, I don't know. This is kind of tricky. What should I do? Right? Well, we're in that situation of, well, what should I do? If someone wants to remove a student and it doesn't exist, what does that mean? Does that mean the helicopter is going to crash now? Or does that mean that we should just ignore it? Or does that mean that, you know, we just say try again? Or does that mean, well, I don't know. But what I could do is raise an exception and make whoever's using my class decide what to do. What were you going to say?
I was going to say, like, can't you
That's effectively what that's doing, right? It's like, well, return a value error, no such student to remove. That's effectively what I'm doing, yeah. So I raise the exception, and then whoever's using this class who said, hey, remove something, and that thing doesn't exist, it's up to them to decide how to proceed. All right, okay, yeah, okay. Contains just calls find, remove, checks if the student exists. So yeah, effectively what we're saying is, okay, well, if it doesn't contain that student, return the value error. Otherwise, just return the student at that, or sorry, pop the student from the index that find gives me. Cool. Any questions? So to go back to your question about like, well, why was find private and remove not? Well, because I want, the things I want to be able to do to my class is I want to be able to create it. I want to be able to add students to it, remove students from it, check if a student exists inside of it, and I want to be able to get the size. We're also going to add like a rep or two or something. That's all I want my class to do. But that's what I need to be able to do with my class. So those are the things that I want to be able to do in order to like interface with my class. So I can go and I can say, my course dot remove. Here, let's see. My contains student whatever 69 should get true and then remove. Oops, what did I do wrong here? No. There. So what did I do? Well, I created the course. I added the student, some student. I added another student with the same name, different student number though. I printed out the course. Hey, do you contain the student, whatever was 69? Now let me ask you this. Here's a quiz. Does the course class define what it means for students to be equal? No. The students know what it means for them to be equal. The course class can ask the students, hey, are you equal? But the course class doesn't actually have control over the definition of equality among its contents, which is a good thing actually. But anyways, we do the contains, yeah, it returns true, great. And then immediately I say, okay, well, remove that student, all right? And then I check, well, does it exist? False. So we know, because we wrote the class, that contains and remove make use of that private find method, but we're not supposed to access it directly. It's a method that is useful and important for the inner workings of the class, but I don't need to interact with it directly. You could think of it as like your car. There's a lot of moving parts on your car that you can interact with, you can interface with directly. You can put it in gear, gas, brake pedal. These are things that are defined in a way so like this is how you interface with the car. But there's a lot of shit going on inside your car that you don't need access to, nor do you want access to. Okay? So this is like this idea of information hiding. Less is more here. Keep it simple. Let the person using your class do what you want them and what they want to do with the class, but that's it. Don't give them more than what they need. Keep it simple. Any questions so far? Yeah. True, true, and true, false. Did you make sure you ran pop? Did you rerun this? Maybe you, like, it's possible that you defined it without, if that happened, You did something wrong, not Python. Make sure that you rerun your class and make sure that your remove does in fact look like this and that you are in fact calling remove. Other questions? Well, now let's write a repr. So here, so we're not going to write an equality because what does it mean for courses to be equal? This is actually quite tricky because, like, do courses need to, like, could courses be equal if they just have the same students in it, or does the order of the students exist in the course? Does it matter? I don't know, right? This is tricky. So a lot of times with collections, we don't define equality. Yeah. Right, like it's kind of, maybe, it's entirely reasonable that someone might want it to be, but in general, we're kind of left going like, I don't know. Equality among collections is tricky. Sometimes, for some collections, it's very obvious. For others, you're left going like, does that even, I don't know, maybe, I don't know. Pardon? The question is wrong, yeah. The premise is incorrect. So now, what's going on with my repr? Well, by the way, every time you print out a list in Python, you see square bracket, thing, comma, thing, comma, thing, comma, thing, where the things are the contents of the list. Someone wrote it to look like that. Someone said, when someone prints out a list, I want you to start with the square bracket, and then put the first thing, the next thing, the next thing, the next thing, and then when you're done, end with this close bracket. Here's what we're going to do. Our repr is going to say, it's going to start with a string, and it's going to be an empty string. Actually, no. I feel like I'm missing something here. I want it to look like this. I'm going to change it slightly. I'm going to say, self.courseName, new line. So what I'm going to do is I'm going to say, my repr is going to be course name, new line, string representation of the first student, or 0th student, new line, string representation of the next student, next student, next student, next student. That's what I want to do. I'm going to return that string. That's what I want it to look like. So I'm hoping I've got an example down here with some good perfect. Let's do this. Oops, I have to rerun this because I never defined repr, and now here we go. So now what do we have? Well, the course name followed by the string representation of the student Bob Smith. And what was, well, that's last name, comma, first name, tab, their student number. Doe Jane, tab, student number. McDonald Niall could write tab. Now, you might be wondering, how come that one's fine? The nature of tabs. The student's name was so long that the tab would have tabbed over another. It's a whole thing. Yeah?
How hard is it to make it align in a way that doesn't make you...
It's not that bad with F strings. It's really not that bad, but there's always going to be some funny edge case. This right here, this type of formatting, when you print things out with tabs and like a lot of programming and whatnot, where you just like output string output, issues like that are so common that like people usually are just like, you deal with it. You just go like, all right, well, whatever. We got another Jane Doe, but they're, oh, well, we've got them twice for whatever reason. That's fine. There we go. Cool. So our repr is actually this like aggregate of the reprs of each individual student in the class. Plus I added a course name to the top, because why not? Any questions about this repr? Maybe. We could do that. We're like, do like contains. If not contains add, otherwise raise an exception. We could do that. There's nothing wrong with that. One might even say, why not just do like a set? Maybe make it, instead of like a list of students, make it a set of students underneath. That's entirely reasonable as well. It all comes down to design decisions. But let's see what that would look like, just for fun, right? Add, okay. if not, let's say if self dot contains if it does, we're going to raise else. There. Well, we don't. We don't. When I do that, this should now raise the exception like, yeah, student already exists. Why? Well, because they did. I mean, all we have to do is do this, and suddenly they don't exist anymore, but whatever. So there we go. We've modified it for fun. Is this more correct? I don't know. Really depends on what you're using it for. This is entirely up to you as the designing of your code. Another thing you might notice is like, okay, well, you know, we've got all these magic methods. Things like, well, the constructor's one, or initializer, repr, EQ, and a lot of them like would come up with like interesting syntax. At the end of the day, most of the interesting syntax for the magic methods all came down to like syntactic sugar, right? Turns out we could do this. Here's hopefully I'm doing this right. In fact, we can get rid of, we can get rid of size. Now, oh, all right, Jane. Let's get rid of that exception just to shut it up for now. So now if I ever wanted the list, like the length of the course, I could just say len of my course. There, 4. So I don't actually have to call size. So that I'm just making use of another magic method. If you like it, great. This magic method just hijacked the lists magic method and just relayed the information back to me, which is fine. But we could do that if we'd like. And do note that with this code right here, it's a single string that spans multiple lines, right? It's not like it's printed 1, 2, 3, 4, 5 separate strings. No, it's one string that's on multiple lines. And that was achieved with the whole /n right there, which adds a new line. There are a lot of ways we could clean this class up with concepts that we haven't really learned yet, so I'm not going to get too much into it. You will notice, however, that now, like if you're using, like let's say I told you, you know, you could open up, you could make a course class. Like you could make a course object and start adding and removing students from it. And you're going to use, oh, this is great, I love this, right? But if I never showed you the underlying code, like listen up, this is an important concept. If I never showed you the underlying code and I just showed you, yeah, here's the class, here's how you interact with it. If I never showed you the underlying code, would you know there's a list there? No. I mean, you may have guessed, but you wouldn't know. Does it matter to you? Do you give a shit that there's a list under the hood? No. You just care that it works and it does what it says it does. Awesome. So that's kind of the idea. First of all, we've created this level of abstraction and you don't even need to know that there's a list under the hood. It's fine. It doesn't matter. The course class works as it's defined. There we go. Awesome. Great. You don't need to interact with that list. You don't want to interact with that list. So don't interact with that list. Easy peasy. The class does all the interacting. It's like the middleman here. It takes the interface like interactions and it does whatever it's defined to do. The program interacts with me, not the internal bits of my class. This is a big concept that might feel like, yeah, I know. Do you? Think about it. Take your time. Just make sure you understand it. Any questions about what we're seeing here? There's a lot of other magic methods we could add to this collection if we wanted. Like, you know how you can add, what happens when you add lists together? They just concatenate, right? Well, we could actually do the same here. We could define what add means for courses, and it just basically will combine two courses. Although I don't really know what you would do with the course name. Maybe it would only work if the course names are the same or something. I don't know. But we could do this. There's a lot of magic methods we could implement. There's a lot of other methods we could implement if we really wanted. If I said, okay, clear. If I want to clear if I wanted to like clear out let's say I have a course with like 50 students in it and I want to kick them all out. What would that method look like? I guess it could look something like this. Let's say, okay, remove all. Right, what would I want this to look like? Well, I guess I could say for I in range of the len of self dot students. I guess it doesn't even really matter, right? I could just say like, size is len of self. Actually, we could do this. Well, my fear with the for loop, and this is because I honestly don't remember what it would do, and to eliminate a potential issue is, like with the while loop, this would be a problem if I said, well, less than the length here. Because the size of that list changes every time through the loop, because it's stateful, right? So the first time through the loop, like I'm saying, well, okay, from 0 to 5, right? Because the 5 is the length of the list, let's say. Next time through the loop, I is, okay, now we're at 1, but the length of the list is 4. So we're actually like counting down at both sides because we've incremented I, but we've also decremented the size. So it could become a potential issue. Maybe Python, I can't remember if Python deals with that accordingly, but I just fixed it by saying, well, just get the size, leave it as a static number, and then run the loop this many times. Now you might notice on line, what is that, 31 there, I'm able to say length of self and not length of, both will work, but this calls the magic method len for the list class because self.students is a list. When I do it on self, it calls length for the course class, which is defined right here, which is just calling the other one. But this actually would work, which is pretty neat, just FYI. We do. There we go. So we could go through and just pop, 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 remove everything from the list. Or we could do what you were getting at, which is, well, you could just go do this. There. You just basically lose reference to, and have I talked about this before? You didn't think of that at all? Well, you should feel terrible about yourself. Imagine I've got some giant ass list, okay? And we have one variable referencing it. In this particular case, it was self dot, so it was an attribute, but it's a variable. We have A referencing this giant list. There's a billion pieces of very valuable information in here. And I come along and I say, okay, A, you actually equal this new list over here. Right? Well, now we've got a bit of a problem. We have this information, super, important. Do not destroy. Yeah, like you said, oops. Because, well, as of right now, this information is stored somewhere in RAM still. But the problem is, we can't get to it anymore because, well, where is it? Don't know, nor can we find out. So, what's happened is if we lose reference to where this crap is in RAM, it's as good as gone. In fact, if we go back in time to like the C days, what time is it? I have 7 minutes. That's plenty of time. To the good old days of like C and C++, we have created what we call, does anyone know what we would call this if this was like C, C++? There's a very special name for this. This was a big word when I was young playing video games because this would happen all the time. But by your age, you probably, this issue never really came up that much anymore. It looks like you had an idea. You want to take a shot at it?
I mean, it was wrong. I was going to say scale reference, but it's not that.
It's called a memory leak.
Yes.
This information is in RAM, and it's used, and the computer's, well, that's okay, yeah, great, there we go. But if this RAM was allocated, and so the computer goes, oh, well, that chunk of RAM I can't use anymore. And if I had a loop and this happened like a billion times, and suddenly I keep allocating all this RAM that's not really used anymore, I use it, but I don't unallocate it, the computer's going to think it's out of RAM. It's going to run out of RAM pretty quickly. That's a memory leak. We got a problem. With more modern languages, they have things built into them called garbage collectors, which basically every once in a while goes, hey, here's something in RAM that has no reference to it, meaning it's as good as gone, meaning it's free RAM again. In the older languages, if you allocated information to be stored in RAM, you needed to deallocate it. You needed to tell the computer, hey, this chunk, I'm going to put information here. And when you were done, you would say, okay, that chunk, I don't need it anymore. Okay. In more modern languages, you could set it aside, and then if you stop using it, the garbage collector comes along and goes well, this isn't used anymore. It's gone. Now, it never actually deletes it. It just frees it to be used later. So the zeros and ones will still be in there. It's just they will get overwritten when the time comes. But effectively what we've done is we've made use of that idea here. Python is one of these more modern languages with a good garbage collector, kind of. Good is the issue, the word I take issue with. Where effectively it has no reference to it. It's as good as gone. It's like I deleted it all. It's empty. Great. Any questions about that?
What word would you feel better about if not good?
It exists.
Yeah, I said functional.
It's functional. Yeah. It is functional, I suppose. It can do its job.
But reluctantly functional?
It's not that bad. But there are some issues, there are issues with it that can become a problem. But although I'm pretty sure in Python you could actually force deallocation, which is nice. In other languages you can't. Anyways, I could be wrong about that. I'm not a big Python expert, but other question, yeah. Like. Well, because I'm always just going to delete the thing at the beginning. Yeah, it doesn't really. So just delete the thing at index 0, and everything moves down. Down, down, down. I just keep. Yeah, that was the idea there. Yeah. Well, the difference, I suppose, is the one I showed you later that did that thing. How many steps was that? Well, the computer goes and creates a new chunk. Functionally, they're the same. However, in terms of like what they effectively accomplish, but this one is, if I have a list of 1,000,000 things in it, how many times does that loop need to run? 1,000,000 times. If I just say, well, create a new list, well, it just does that. So it takes less steps. However, there is some overhead associated with creating a new list. So it gets complicated. Yeah. So there is some like overhead. But from a purely like theoretical in terms of computation, the iterating over would be worse. But from like an implementation, like engineering Python thing, there is some like catches to it. But purely from a computational perspective, one is better than the other in terms of like the computational complexity. Other questions? These are great questions, by the way. Which leads us to the next topic perfectly. With 2 minutes, when we start talking about complexity. Look at that. It's well defined, don't worry. Anyways, we'll pick up here on Friday. By the way, I'm sorry to tell you, we only have 3 classes left. I know. Tuesday, yeah. So, I know. Yeah, I know. Fortunately, if you're taking 162, you won't miss me.